Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything you need to know for the upcoming test. So the test has three sections. One is one variable equations and inequalities. The other is two variable equations and inequalities, and the third section is statistics. So let's look at our first section. So whether you're solving one variable equations or inequalities, the goal is the same. We want to get the x, or whatever the pronumeral is, into one spot and then undo what has been done to it in the opposite order to BIDMAS. So for something like 35 minus 9x is less than or equal to 71, we're going to solve it very similar to an equation. So this 35 here is positive, so I'm going to subtract in order to get rid of it. My goal is I want to get x by itself. So my next line, I just get negative 9x is less than or equal to 36. Now there is one difference between equations and inequalities. When you're solving an inequality, if you multiply or divide each side by a negative, you must reverse the inequality. You see here I've got negative 9 times x, so to undo that I have to divide by negative 9. What you do to one side you must do to the other. So because I am dividing each side by a negative, I need to switch the inequality. So it will become x is greater than or equal to minus 4. So that's the only difference between solving equations and inequalities. You must remember to reverse the inequality sign whenever you multiply or divide each side by a negative. Now, when you have the pronumeral on both sides of the equation, the goal is we need to get the pronumeral so it's only in one spot, and then we undo what's been done to the pronumeral. So when you have the pronumeral on both sides, first get rid of any fractions or brackets, and then what we do is we subtract the x with the lowest coefficient. So here, this one has coefficient negative 7 and positive 7. So since negative 7 is smaller, I'm going to subtract negative 7x from both sides. Of course, subtracting negative 7 is the same as adding. The reason I'm doing this is I will get x to one spot because negative 7x plus 7x, they cancel out. I'm left with 15 is less than or equal to 14x minus 13. Simply add 13 to both sides and divide by 14. So here I get 2 is less than x, which is exactly the same as x is greater than 2. So if you are asked to graph a number line, make sure your number line has arrows. All you do is mark the number. So for negative 4, just going to put that in the center, just going to put a number on each side. Now, when it is a strict inequality, so it's one of these, you use an open circle. And if it's not a strict inequality, it's one of these ones, you use a shaded circle. So here I'm going to use a shaded circle. We're just going to start at negative 4, and we're going to point to all the numbers greater than or equal to negative 4. This shaded circle indicates that we're including this negative 4. Negative 4 is a solution. If you substitute it in here, you get a true statement. On the other hand, for this one, I'm still going to mark 2 in the middle of the number line, but I'm going to use an open circle because this is a strict inequality. So I'm going to point to all the numbers greater than 2, but not shading this in indicates that 2 is actually not a solution. If you substitute x for 2, you do not get a true statement. All right, let's look at a harder equation. So we're going to attempt this one here. So when you have the pronumeral on both sides, first step, get rid of any fractions or brackets. I can get rid of this fraction by timesing by 11 and this by timesing by 2. So I'm going to times by 22 in both cases to get rid of both fractions at once. What you do to one side, you must do to the other. So if I times this by 22, I can put a 22 up here, I can cancel out 22 divided by 11 is 2. So I'm left with 2 outside of 20 minus 3x. Now when you're timesing one side of the equation by number, you have to times the whole shebang. I have to times this one by 22 as well. Now, when I times the right-hand side by 22, 22 divided by 2 is 11. I can just write it like this. So I have got rid of the fractions. Now I want to get rid of the brackets. I'm going to do that by expanding. So 40 minus 6x minus 66x and so on. I'll now collect these like terms here. So that gives me 40 minus 72x. So now, in order to get x to one spot, I'm going to subtract the x with the lowest coefficient. So I'm going to subtract negative 72x, which is of course the same as adding 72x to both sides. So I get 40 equals 176, and of course negative 55 plus 72 is 17x. Then you simply subtract 176, divide by 17, you get x equals negative 8. Now, if you have time in the test, check your solutions. All you have to do is substitute this into the original equation and see if you get a true statement. All right, let's now look at equations or inequalities with two variables. So I'm going to go ahead and graph this inequality with two variables in the Cartesian plane. So your first step is to graph the line. I'm just going to replace the inequality sign with an equal sign. I'm going to graph the line negative 4y plus 3x equals 12. Now when you're graphing the line, you need to use a dashed line if the inequality is strict, so if it's one of these two, or you use a solid line if it's not strict. So because this is a strict inequality, I'm going to graph this line using a dashed line. So how do I graph this line? Well, when y is not the subject of the equation, we use x-y-intercept method. What we do is we let y equals 0 to find the x-intercept and x equals 0 to find the y-intercept. If y equals 0, this just becomes 0. You get 3x equals 12 and x equals 4. If x equals 0, that goes away. You get negative 4y equals 12, y equals negative 3. So let's plot those. The x-intercept is 4, the y-intercept is negative 3. When we need to graph an equation, if it's a line, all we really need to do is find 2 points through which the line passes and join them up. So I'm going to join these up, but using a dashed line. Now make sure that your line has arrows on it. So we've graphed the line. The next thing we need to do is decide whether I shade this side of the line or this side of the line. So what we can do is pick a test point. Any point will do as long as it's not on the line. So if 0, 0 is not on the line, let's pick that because that's an easy one to use. Now we need to substitute 0, 0 into our original inequality. That means I change y and x to 0. If y and x are 0, I get the statement 0 is greater than 12. That is clearly false. That means that 0, 0 is not part of the region we want to shade. So rather than shading this side on which 0, 0 lies, I'm going to shade the other side. So what have we actually done here? We have shaded in all of the points that satisfy this inequality. Any point in this region, if substituted its coordinates for y and x, will yield a true statement. In here lies the infinitely many solutions to this inequality. The dashed line indicates that points on this line are actually not part of the required region. All right, let's now look at simultaneous equations. So we're now looking at equations with two variables. We will have two equations and two variables or pronumerals. This equation has infinitely many solutions, so too this has infinitely many solutions, but we're going to calculate the solution that solves this one and solves this one at the same time. That's what simultaneous means. We went through two methods. The first one is substitution. We use substitution when we have y or x as the subject of one of the equations. Since y is the subject here, let's use substitution. So with substitution, what we do is take the equation that has x or y as the subject and substitute it into the other equation. So what exactly does that mean? So that means I'm going to take my second equation here, and everywhere I see a y, I am going to replace it with 3 minus x. Now, when you're doing such a substitution, use brackets. We've now reduced this to one equation with one variable, which is very easy to solve. So expanding the brackets, I distribute the negative sign to the 3 and also to the x. So negative x is positive x. Make sure you understand that because people often make the mistake in this situation of writing negative x there. So we now simply collect the like terms, and you know how to solve this. We're going to add 3 to both sides and divide by 6. We get x equals -2, but I'm not done there. I need to find the y value. So I'm going to substitute it into either equation will do, but I'll choose this one because it's much easier. So y is simply 3 minus -2, which is 5. The solution to this simultaneous equation is -2, 5. If you were to graph this line and graph this line, they would intersect at this point. So that's substitution when you have either equation having x or y as the subject. What if you don't have either x or y as the subject? Well, that's the case in this one here, and we have another method for that, elimination. It's so called because I want to eliminate one of the variables x or y. The one you eliminate is the one that has the same equation. You might be here. Y has the same coefficient in both equations. So what we're going to do is multiply one or both equations so that they do have the same coefficient. So I could multiply this equation by 5 and this by 3. That would make the x's have the same coefficient. But I'm just going to multiply this top one by 3. If I multiply this top one by 3, then the y will have a -6 in front of it and will have the same coefficient. So when you're multiplying an equation by a non-zero number, you need to multiply everything in that equation by the number. So I need to multiply 3x by 3, -2y by 3, and also 29 by 3. Now I'm going to leave the second equation alone. So now that y has the same coefficient in both equations, I can eliminate it. So how we ultimately eliminate is using this rule here. If the x or y's have the same coefficient and the same sign, you subtract one equation from the other, and if they have a different sign, you add the equations together. So what I mean by that is the y's here not only have a 6 in front of them, they're also the same sign. They're both negative. So what I can do is eliminate the y by subtracting one equation from the other. It doesn't matter if I do top minus bottom or bottom minus top. So what I'm going to do here to get rid of the y's is I'm going to subtract. So 9x minus 5x is just 4x. Now -6y, subtract -6y is 0. That's why I'm doing it, to get rid of the y's. 87 minus 59 is equal to 28. So 4x equals 28. I get x equals 7. Substituting that into any of these equations, which one doesn't matter, I get y is equal to -4. So the solution here is 7, -4. I can easily check my solution by substituting the x and y value and seeing that it satisfies both equations at the same time. All right, let's now look at a worded problem. So let's look at this worded problem here. In a school of 500 students, 70% of boys and 75% of girls were born in Australia. So 364 students were born in Australia. We'll calculate how many boys, how many girls attend the school. So whether you're solving a worded problem in simultaneous equations or just using plain old equations, our first step's always the same. We define a variable. So we're going to let x be one of the things we're trying to find. I'm just going to let it be the number of boys. Now in this problem, we need to find two quantities at the same time. So at the same time means simultaneous equations. We're going to solve this using simultaneous equations. So we've let x be one of the things we're trying to find. We'll let y be the other thing we're trying to find. Now we need to set up two equations from the two bits of information. First bit of information says there's 500 students. So number of boys plus number of girls is equal to 500. The next bit of information says that 70% of boys plus 75% of girls. If I take those students, I have 364 of them. So we have our equations. We need to decide to use elimination or substitution. I'm going to use elimination. I want to eliminate x or y, but neither has the same coefficient in both equations, so I need to multiply one or both equations. I'm going to multiply the top equation by 0.7. That means the x is multiplied by 0.7, so to the y, and so to the 500. Okay, so now we have x with the same coefficient in both equations. It has the same sign. I can eliminate x by subtracting. So 0.7x minus 0.7x is 0. That's why we did it, to get rid of the x's. I then have 0.05y equals 14. So y is just 14 divided by 0.05, which is 280. And if x plus y equals 500, so then x is obviously 220. So for these worded problems, make sure you answer with a sentence. So you just say something like, therefore, there are 280 girls, because girls was y, and there are 220 boys. All right, let's now move on to statistics, the final section of the test. So first we look here at box plots. So box plots are a way to display data. More precisely, they display the 5-number summary. Q0 the minimum, Q1 is the first quartile, Q2 the median, Q3 the upper quartile, and Q4 the maximum. So Q3 minus Q1, here it's 4 minus 1, it's 3. That's called the interquartile range. The interquartile range is the difference across the middle 50% of scores. What box plot do is roughly divide the data into 4 quartiles, basically in 4 groups. So there's the same number of scores in this group, this group, this group, and this group. About 25% of scores in each group. So how do we actually calculate this 5-number summary? Well, let's look at these scores here. Now, Q0 and Q4 are easy as. It's just the minimum and the maximum. You probably knew how to find Q2, the median, in year 7. So what we do is divide the data in half. So this is 8 data points. The median is here. When there are 2 middle scores, the median is the average of the 2 scores. Add them up and divide by 2. So here, 57 is the median. Now, Q1 is the median of the lower half. So it will be here, halfway between 42 and 45. It'll be 43.5. Similarly, Q3 is the median of the upper half of scores. So of these 4 scores, there are 2 middle again. The median is halfway through. So Q3 will be halfway between 67 and 83. It will be 75. So here, the interquartile range of this data down the bottom is simply 75 minus 43.5, which is simply 31.5. The interquartile range is basically the range of the middle 50% of scores. And we could easily turn this into a box plot if we wanted to. All right, let's now look at standard deviation. So these are the formula for population and sample standard deviation. They're pretty much exactly the same, except for population you divide by n, for standard deviation divide by n minus 1, where n is the total number of scores. Note that mu and x bar both refer to mean. This is just population mean. And this is sample mean. You calculate them exactly the same way. And that is always the first step for standard deviation calculations. Calculate the mean. Simply add up all the scores and divide by how many there are. So after that, I suggest creating a table. So first column is xi. That refers to each individual score. So x1 is 8, x2 is 12, and so on. So what we need to do here, what this is saying, we need to take each score and subtract the mean. So we go 8 minus 14, that gives us -6, 12 minus 14, and so on. So then what we do is we take each of those values I've just calculated and we square them. So negative 6 squared, negative 2 squared, and so on. Now just remember, when you square a negative in your calculator, put brackets around it. The answer you get should always be non-negative. If you square a number, the answer's not negative, it's either 0 or positive. So that's this part here done. Take each score, subtract the mean, and square them. This symbol here means add up all of these values. So I'm going to add up these 4 values here. That simply equals 80. So if I want the population standard deviation, I take the square root of 80 over 4. N means the number of scores, and there are 4. So it's just the square root of 20, which is about 4.47. If I was calculating the sample standard deviation, it'd be the square root of 80 divided by 3. So putting that in our calculator, we get about 5.16. So just make sure to read carefully the question. Did it ask for population or sample standard deviation? Because the answers are slightly different. So what have we actually calculated here? Well, the standard deviation is the average distance of scores from the mean. So a low standard deviation means scores were clustered around the mean. A high standard deviation indicates that scores were well away from the mean. You might have had a lot of low scores, a lot of high scores, etc. All right, last thing we need to go through related to this is z-scores. So this is the z-score formula. You take a score and convert it to a z-score by taking that score, subtracting the mean, and dividing by the standard deviation. Z-score tells you how many standard deviations a score was above or below the means. So a z-score of 0 means it was equal to the mean, positive z-score means above the mean, negative z-score means below the mean. And the idea is it kind of standardizes scores. You know, if you say you got 90% in a test, is that a high score? Well, that's hard to judge. It depends on what the mean and standard deviation were. But if we convert it to a z-score, it allows us to see a lot more whether it was a high or low score. For example, in college, if you get a z-score of 2, you're 2 standard deviations above the mean, that means you were awesome. That means you were generally well above most other people. Whereas if you get a z-score of, minus 0.5, it says that you were only slightly below the mean. So let's do a question on this. Let's say I scored 80% in a test with a z-score of 2.2. My friend scored 43 with a z-score of minus 1.5. Calculate the mean and standard deviation. So hopefully you're thinking that because we're finding 2 quantities at the same time, we're going to need to utilize simultaneous equations. So the first equation I get from this information, 80% z-score was 2.2. So I'm just going to take this formula. I'm going to replace z with 2.2 because that was the z-score. I'm going to replace x, which is the score, with 80. Now, I know neither the mean nor the standard deviation. So this is my first equation. I can rewrite it a little bit easier as 2.2 sigma equals 80 minus mu. Similarly, a score of 43 yields a z-score of negative 1.5. So z equals score minus mean over standard deviation. Again, I'm just going to times each side by sigma because that just makes it a little easier to work with. So now I have 2 equations with 2 variables. I'm going to use simultaneous equations. Here, the mu has the same coefficient in both equations. Once again, they have the same sign, so I'm going to subtract the equation. 80 minus 43 is 37. Negative mu minus negative mu is 0. That's why I did it. I wanted to get rid of the mu's. On the other side, I need to do 2.2 sigma minus negative 1.5 sigma, which gives us positive 3.7 sigma. Divide each side by 3.7. I found that the standard deviation is 10. Now I can simply substitute that into any of the equations. I'll just do it in this one. So I get 2.2 times 10 equals 80 minus the mean. So the mean's simply 80 minus 22, which is 58. In this question, the mean was 58, the standard deviation 10. Alright, thank you so much for tuning into this video. Best of luck studying, but don't worry, you will ace the test. You're a star. This has been the luckiest maths teacher in the world. Have a great day.